Thank you, Eric, for the introduction. As Eric already explained, I will present the Life Remind Water project that was about brine minimization in mining industries. This project started on October 2018 and finished it on October last year and had a total budget of 1.8 million euros. It was coordinated by Getaqua and had the participation of Sandfire Matze, who was the owner of the case study. Sandfire, Matze is a mining industry located in the southwest of Spain. Then there was also the participation of EMM, that is an Institute of Non-Ferrous Metals in Poland. And finally, the participation of New Heat, which is a French company that provides thermal energy by means of renewable energies, especially solar panels. So in this project, what we wanted to do is to change this conventional workflow normally applied in the mining industry that consisted on producing processed wastewater that then went to the industrial wastewater treatment plant to finally be discharged into the environment. With Remind Water, we wanted to change this linear process to a circular process. How? By installing this advanced treatment plant that treated the discharge from the wastewater treatment plant to minimize the brines that went to the environment and to recover water to be reintroduced in the production process. In addition, in this project, we also constructed another plant that is called the resource recovery plant that has the objective of recovering metals and sulfuric acid, also from waste dumps, to be reintroduced into the process. Since this is not devoted to brine minimization, I will not go into detail to this part, but I wanted to mention just to know that if you are interested, there was also this other part that was developed under this project. So, in the conventional workflow, the Matze wastewater treatment plant follows this route. First, Matze treats their acidic water that had a pH of between 2 and 3 with a high sulfate concentration as well as high chemical oxygen demand amounts. The first step consisted on a phantom process where the thiosalts were oxidized by means of the addition of hydrogen peroxide. And then there was a second step where sulfate precipitates by means of lime addition and sodium aluminate. The sulfates here precipitated as gypsum and ettringite. Then the water was treated and was stored in a buffer pond before being discharged in the environment. The point here that in addition to the high amount of water that they were discharging to the environment that were not valorized, there was also the problem of the quality of the water that they were discharging. In this case, their sulfate concentration was still high, was about 1,900 ppm. And in the near future, they will have to lower this value down to 900 ppm. So this current technology based on sulfate precipitation, chemically sulfate precipitation, is not able to reduce this limit. So they need to find another one that can attain this strict limit. And this is where Remind Water applies to give a solution. So in the project, what we treated is the water that went out of this phantom process. So it's already neutralized water with a lower amount of chemical oxygen demand, but still high concentrations of sulfates. Here you can have a full view of the Matza wastewater treatment plant here. And inside the red circle, there is the Remind Water pilot plant that was built. If you follow this QR, you can also have a virtual tour to this plant that is available on the Remind Water project website, and where you can go into detail on the technologies that has been tested. This is another view of the pilot site. On the background, you can see the waste dumps from the mining, while in the foreground, you can have another view of the pilot installation. And here there is another closer view where you can see the size of the units that were constructed. So as I explained, in the Remind Water project, we built a water reclamation plant that consisted of two different systems. The first one was devoted to sulfate removal, and the second one to minimal liquid discharge process. Now we will explain the details of this one of each one of these units. The first part, the softening, had the objective of removing water hardness. And for this, we added sodium hydroxide and CO2 to precipitate a mix between calcium carbonate and magnesium hydroxide. And with this, we achieved about 70% of calcium removal and 60% of magnesium removal. At the inlet of the water treatment plant, the flow rate was about 4 to 6 cubic meter hour. In the next step, the water going out from the softening entered to a sound filtration unit which remove the particulate matter, and then there was the addition of hydrochloric acid to adjust the pH before going to the nanofiltration membranes. Here in the nanofiltration membranes, the objective was to remove the divalent ions. So from one side here, in the concentrate sulfates were concentrated to about 3,000 milligrams per liter, while in the permeate, they were clearly reduced. So in the permeate, working at a percentage of 75% of water recovery, 95% of calcium were removed, 95% of sulfate were removed, and about 60% of total dissolved solids were removed. Then the nanofiltration permeates went to the reverse osmosis step. And here, again, the objective was to remove monovalent ions from the dissolved phase. And these monovalent ions were concentrated in the reverse osmosis concentrate, while in the permeate, a high quality water was produced. So in general, 97% of TDS were removed, and almost all the sodium chloride that was present in water. And the reverse osmosis stage worked with a percentage of 90% water recovery. So from now on, the next steps are devoted to concentrate the brine, so minimize the volume of them, and increase their salinity to prevent their discharge and increase water recovery. So this minimal liquid discharge consisted on First, treat the reverse osmosis concentrate through an electrodialysis brine concentration technology. And from here, we produce two streams. The diluted stream from the electrodialysis was conducted again to the was mixed with the nanofiltration permeate to be treated again to the reverse osmosis. And while the concentrate from the electrodialysis was able to concentrate salts 2 times, so and until reaching a TDS of about 10 grams per liter. In this case, we expected a higher concentration factor in the beginning, but for technical reasons, this salt concentration factor could not be optimized. But with the optimized functioning, probably it could be reach a salt concentration factor of about 10 to 20. Then the electrodialysis concentrate went to the low temperature evaporator, commercially known here as CEVAP. And this technology was able to concentrate salts from 10 grams per liter to up to 100 grams per liter. And what it is interesting here is that this low temperature evaporator was coupled to solar panels that provided them thermal energy. So in terms of energy, it was more efficient and had a lower cost than if we had to work with electrical energy, with non-renewable sources. At the same time, the low temperature evaporator produced a condensate that was also of high quality to be reused in the production process of the mine. Going into detail to this low temperature evaporator and solar plant, as here you can have an overview of this equipment. And this equipment was coupled to what we see here in the right picture. Importantly, there is the solar panels that provide, as I mentioned, provided solar thermal energy to heat water that was stored in this tank. And then there were all the hydraulic station that was placed inside this yellow container. And also there was a glycol storage that is the liquid that was employed for the internal loop of the solar panels. So the CEVAP consists on the multi-effect distillation, which in this case had 4 effects. The effects are each one of these stages that we can see here. And inside these stages, there is the cartridge are places. So CEVAP comes from cartridge evaporator, is what it means. And the advantage of this technology is that it is more efficient in terms of energy because it profits the vapor from the last stage to heat the next one. And in addition, it works with vacuum, and which implies that the temperature to be applied is lower. So in general, this solution is interesting because it will decrease the operational cost of the evaporation to concentrate brines. And going into the detail of the test, with the test that we have performed, here we apply different for temperature from 65 to 85 degrees. So the VAP works always below 90 degrees. And then here we have the condensate flow rate. We increase it with the higher temperature. And then the maximum achieved conductivity on the concentrate, that except for this point at 80 degrees. So normally it increases, which is logical, with the higher temperature. This is what what can be observed also in this plot. So the yellow line, we can see that at 80 degrees, we achieve a maximum concentration of 2 millisiemens per centimeter. That is more or less equivalent to this 100 grams per liter TDS. And with this point, we achieve a brine volume reduction of more than 95%. And the cost is associated to that, according to the suppliers, is 2.64 euros per cubic meter of feed water. And this cost is a little bit high, and it's due because of the high cartridge replacement cost, not due to the thermal energy. Here during the project, we did some calculations about the energy costs, but I did not include it here because it depends on where you have in case you work with solar panels, where you are located. So in the southwest of Spain, we have lots of solar energy, but probably not in other sites, it will change. So just taking into consideration the material cost will be this one. So as a conclusion from this project was that we developed an innovation treatment drain from brine minimization that reduces in a global context regarding all the water balance, was able to reduce the freshwater consumption that the mine did on the past by 50%. In addition, this water reclamation plant recovered 95% of the water from reverse osmosis concentrate to the implementation of the minimum liquid discharge that I present you. And we were able to concentrate the brine from 5 grams per liter TDS in the concentrate of reverse osmosis up to 100 grams per liter in the evaporation concentrate. And that's it from my side. So thank you very much for your attention.